The global asset management industry controls trillions of dollars, operating largely on the speed of legacy mainframes. But now it is colliding head-on with digital networks that settle transactions in milliseconds. The conflict at the center of this collision is compliance. Trillion-dollar financial institutions are legally mandated to use strict, centralized custody models. That requirement seems entirely incompatible with permissionless, decentralized blockchain architecture. Enter Baillie Gifford, a prominent asset management firm based in the UK. They manage over £200 billion in traditional assets for major global clients, placing them among the industry's most significant heavyweights. Yet this massive traditional institution recently launched a fully functioning tokenized bond fund on public blockchains. How did a firm responsible for hundreds of billions in capital deploy decentralized technology without breaking strict UK financial custody laws? The solution relies on the structural workaround. They didn't change the nature of the asset. Instead, they completely rebuilt the architectural relationship between the physical asset and the ledger that tracks it. This diagram illustrates how they solved the paradox by modularizing the fund into two distinct layers, off-chain custody and an on-chain ledger. Looking at the off-chain layer, the physical bonds themselves are not tokenized. Shifting to the on-chain ledger, you can see what actually moves: the legal ownership records, the contractual right to the fund's shares. The second major architectural decision here is network redundancy. This on-chain ledger is deployed across two completely separate blockchains simultaneously, Ethereum and Solana. This multi-chain deployment represents a pragmatic shift for institutional finance. Asset managers are choosing specific technical optimizations over loyalty to any single blockchain ecosystem. To understand the future mechanics of institutional real-world assets, we have to deconstruct exactly how this dual-chain architecture operates, layer by layer. We'll start at the foundational layer, the underlying physical assets. Looking at this 1893 paper bond certificate, you can see the heavy physical nature of the asset class. While modern bonds are rarely printed on paper like this, they represent the exact same tangible obligations: UK government and corporate debt. Despite the digital wrapper of the tokenized fund, these underlying debt obligations remain entirely off-chain, locked in traditional, highly regulated custody facilities. Keeping physical custody off-chain perfectly satisfies existing UK financial regulations regarding asset custodianship. The state knows exactly where the debt is and who holds it. This physical separation acts as a security firewall. It isolates the core value of the fund from any potential smart contract vulnerabilities or blockchain network hacks. Unlike purely synthetic crypto assets that only exist as code, this fund represents enforceable claims on actual real-world debt backed by state and corporate entities. Within this mechanism, the traditional financial custodian acts as the ultimate guarantor of those physical bonds, ensuring the capital remains solvent. By isolating the heavily regulated assets off-chain, Baillie Gifford secured a compliant foundation. That foundation gives the digital layer above it total freedom to operate at network speed. Shifting our focus upward, the off-chain vault connects to the digital layer. A data stream flows up, generating the on-chain ledger. This data organizes into a capitalization table, tracking legal ownership records of the fund shares, securely linking digital wallet addresses to share amounts.
Historically, tracking ownership required analog tools. As seen in this blue National Savings Certificates booklet and manual holder's card, legacy systems relied heavily on ink signatures, date stamps, and physical record-keeping. In this modern model, the blockchain acts strictly as a distributed capitalization table and settlement layer, entirely replacing those paper booklets and manual back-office databases. When you encode these ownership rules directly into smart contracts, the transfer and settlement of fund shares becomes automated. That automated settlement strips out the administrative bottlenecks, significantly reducing back-office operational costs for the asset manager. It also provides a mathematically verifiable, real-time audit trail for investors that anyone can query at any time without waiting for quarterly reports. This system eliminates the friction of transferring legal ownership, transforming a slow administrative chore into instant executable code. Notice how the on-chain ledger splits into two parallel branches, Ethereum on the left and Solana on the right. Why divide operations? Starting on the left branch, Ethereum offers a deeply mature, battle-tested ecosystem with significant institutional support. Ethereum serves as the high-trust settlement layer, built for clients mandating maximum security. Pivoting to the right branch, Solana is engineered for something else entirely: drastically higher transaction throughput. Solana functions as the high-efficiency execution layer. It handles rapid transfers while compressing transaction costs down to fractions of a cent. When analyzed together, these two networks aren't cannibalizing each other. They complement each other perfectly within a single fund structure. Bailey Gifford's deployment strategy acknowledges a hard truth in modern decentralized finance: no single blockchain is currently perfect for every institutional requirement. By utilizing a dual-chain architecture, the fund allows institutional investors to route their operations based on specific priorities, balancing security, scalability, and cost efficiency on a trade-by-trade basis. Zooming out to view the entire blueprint in a single frame, you can see how traditional custody at the base feeds directly into the smart contract layers at the top, locking together seamlessly. For years, the dominant narrative was that crypto networks were built to bypass and completely replace traditional banks and clearinghouses. This £200 billion asset manager proves that assumption wrong. Institutional adoption at this scale is entirely about integration, not replacement. The legacy infrastructure of the custody vault and the decentralized execution environments of Ethereum and Solana are mutually dependent in this model. One holds the collateral, the other provides the rails. Distributed ledger technology has matured into a utility layer. It augments existing financial plumbing to make it faster, cheaper, and highly verifiable. Bailey Gifford's regulated approach provides a tested blueprint for the entire asset management sector. By tokenizing legal ownership records rather than the physical assets themselves, they solved the exact regulatory friction that kept Wall Street and the City of London on the sidelines for the last decade. This specific modular dual-chain architecture provides a legal and technical framework that will likely trigger a wave of similar real-world asset tokenization from other major financial institutions. As this architecture scales, we are looking at a framework that can move institutional capital globally without the friction of the past.